Hello, my dear students. I welcome you all to Chakravarti Science Academy. Today, I'm going to discuss a very important topic in coordination compound, that is how to write the IUPAC naming of the complexes. Remember, one question is assured in the board exam, or if you're writing the entrance exam, it is one of the high probable question which is going to be asked, that write the IUPAC name of the coordination compound. So first I'm going to brief you with some important rules, and then I'm going to give you some examples, and we can do the solving. So now, first thing is, before we do the IUPAC naming, you have to be comfortable with some of the important negative ligands, neutral ligands, and positive ligands. So I'll tell you how do we write the name of such ligands. So first of all, you can see we are going to talk about anionic ligands. Anionic ligand means those which carry the negative charge. So we call them negative ligands. So in this case, you will see very first example is chloride. So understand, whenever you have a negative ligand, whatever their name ends with, see, Cl minus is called chloride. Now, for example, for chloride, you will remove the last alphabet, that is E, and you will replace it with O. E will be striked off and you will replace it with O. So it becomes chlorido. Similarly, if you have sulfate, it will become sulfato. Means the ending of the only for negative ligands. In the IUPAC naming, for the negative ligands, you will strike off the last alphabet and you will replace it with O. Okay, so that is why chloride became chlorido, bromide became similarly bromido, and cyanide became cyano or cyanido. Okay, oxide became oxo. Similarly, if you strike off peroxide ka E, it will become peroxido or peroxo. Similarly, oxido or oxo. And you have to remember the difference between oxide and peroxide. Understand, oxide ion is basically an atom which has a valency of oxidation number of -2. Peroxide is a molecule, so it's O2, and it has a oxidation number of -2, same as oxide. For hydroxide, it will become hydroxo or hydroxido because you will strike the E off with O. Similarly, sulfide became sulfido, amide becomes amido, imide will become imido. Now again, for amide and imide, you have to be careful. They understand, in amide it's NH2, imide it's just NH. And in case of amide, the oxidation number is -1, but in imide oxidation number is -2. Then we have nitride. Nitride, we know it's nitrogen only, and E will be replaced with O, so it becomes nitrido. Phosphide will become phosphido. Now we will see some more negative ligands. So here we can see carbonate becomes carbonato because you will replace the E with O. Similarly, you can see some more, that is the oxalate. Okay, oxalate is basically derived from oxalic acid. You can see this is oxalic acid, and when the hydrogen H plus ion is removed, this is the C2O4, 2 minus. So that is oxalate became oxalato because you have removed the E with O. Sulfate became sulfato, nitrate became nitrito, and sulfite SO3 2 minus becomes sulfito, and thiosulfate is S2O3 2 minus. So thiosulfate became thiosulfato. The last E, but you have to do, again I'm reminding you, only in the case of negative ligands. Acetate become acetato. Now, these last four ligands are very important. They are very special. Why? Because they are called as okay, because they are called as ambidended ligands. So write it down. Last four are called as ambidendate ligands. Now, what do you mean by ambidended ligands? So such ligands basically donates only one pair of electron to the ligands, but they have two donor centers. Such ligands have two donor centers, means here sulfur can also donate, nitrogen can also donate. So, but only one will be active, one will be donating at a time. Such ligands are ambidentate. That is why SCN. So when it's written as CN, then sulfur is the donating site. Okay, when it's written as isothiocyanate, okay, then it is nitrogen is the donating center. Okay, nitrite. When it's written as nitrite, it is ONO. Okay, ONO. And this time oxygen is the donation center. See, in this case, ONO can be nitro also. When it's nitro, it is NO2. Then nitrogen is the donor center to the central atom. All right. Hope it's clear. So ambidentate means, see, ambi means dual. So ambi means two donor center, but one is donating at a time. So when it's thiocyanate, it's sulfur, SCN. Isothiocyanate, then NCS, nitrogen. Then it's nitrite, it's ONO, and nitro means NO2. Now, why this ambidentate is ligand is important? Because there is a rule that when you have ambidentate ligands, any of these four, okay, or I'll today. Okay, later on. Later on, I'll tell you the rules. What is so special about the ambidentate ligands? So follow it up. Now here are some neutral ligands. Remember, neutral ligands oxidation number for oxidation number of all the neutral ligands is zero. So what these examples you have to remember. First is the pyridine C5H5N. Second, you have triphenylphosphine PPH3. Triphenylphosphine. Okay. Third, dioxygen H2O. Remember, H2O is aqua. The name of H2O is aqua. NH3 is called amine with a double M. Okay. CS is thiocarbonyl. CH3 is called methyl. CO is carbonyl. CS is thiocarbonyl. Okay. N2 is dinitrogen. NH, then you have one ethane, one, two diamine. All right, ethane 1, comma 2 diamine. Here you have two carbons and they each have NH2 groups. So this is ethane 1, 2 diamine. All right. Then you have urea. You know urea formula? Urea formula is this. This is urea. Okay, NH2CO, NH2. Now remember, in place of oxygen, if you replace it with sulfur, then urea becomes thiourea. All right. Then you have NO, which is called as nitrosyl. Okay. C6H5 is phenyl, C2H5 methyl, CH3 is methyl, and so on. So these all have oxidation number 0. And these names you have to remember. Okay. Now we'll see the next. And remember, in negative or positive ligand, we don't do this thing that we remove the last alphabet with the O. We do that only in case of negative ligands. Next, we have a positive ligand. So positive ligand, only few examples are there. NO plus, that is nitrosonium. Okay, NO2 plus, that is nitronium. And then you have NH2, NH3 plus, that is hydrazinium. We know this is hydrazine. NH2, NH2. You can see that NH2, NH2. This is hydrazine. So NH2, NH3 plus, that is hydrazinium. All right. So these are the few positive ligands. Now we will start with the IUPAC naming. All right, we will scroll it down to see the next part. We'll do some questions. So with questions, I will explain it to you how to write the IUPAC name. Remember, the first rule says that you should write the name of cation. All right, the first rule says that you should name the cation which is outside the sphere. Okay, then second rule says number and name of ligand. And remember, if you have a heteroleptic complex, that means if you have different type of ligands, then you have to write the name of ligand in alphabetical order. Like A comes first, then B, then C, then D, and so on, like dictionary. Then it says after that, finally writing the names of the ligand, then you have to write the name of central metal atom, okay, followed by its oxidation number in Roman, enclosed in brackets. So first you'll write the name of the metal, and then you will write the oxidation number in Roman to be enclosed in a brackets. But here there is a important point that if you have an anionic complex, well, in that case, means if the sphere contains not positive, the negative charge. Okay, I'll show you such examples. If you have an any complex, such as your coordination sphere has a negative charge over here. All right. Then in that case, central metal atom name ends with suffix. Then central metal atom name will end with a suffix 8. It will end with a suffix, so that is 8. A, T, E. Okay, 8 you will add in the end. For example, when it's lead, you will say plumbate. When it's copper, cuprate. Silver, then you will write argentate. All right. Now, so, and fourth rule says, finally, at the end, you will write the name of what is missing. That is name of anion. So these are the four basic rules that you have to remember. There are few more add-ons which I will tell you while solving the questions. So let's see the first one. So if you see, first we have to calculate the oxidation number, because you know we need that oxidation number to be written in the name. So what is the oxidation number of silver X? We have learned that amine is a neutral ligand, if you remember. So its oxidation number is 0, and the sphere has a charge of positive. So what is X? So X will be plus 1. So when X is plus 1, then what will be the name? So first number and then name of the ligand. So how many ligands are there? Two. Two ligands. So di. So di, and what was the name of NH3? Amine with a double M. So write down diamine. So it is diamine. After that, you will write the name of the central metal atom, and it's a positive or neutral, then you don't have to write ATE. Only when it's negative charge on the sphere, then you will write the ATE word. So silver, diamine silver in the oxidation number, that is 1 in Roman, and because there is no cation, no anion, so put ion. That's all. So this is the answer. Now let's discuss the second one. Now in the second one, if you see, we actually have multiple type of ligands, three type of ligands. So when you have multiple ligands, then its name to be written in alphabetical order. So how do we write the name? So first of all, there is no cation, no anion is there. This is the anion outside the sphere. We will write it in the end. Now, so how do we write it? So first of all, amine comes first. So tetraamine, because 4 is there. So tetraamine with a double M. Tetraamine, after that aqua. Br is bromido. Remember negative ligand, it's -1. This is neutral, this is neutral. And because nitrate has a -1 charge. So what is -1 into 2? That is +2. The equal and opposite charge you will put on the coordination sphere. Whatever the counter ion means, whatever the anion or cation is there, equal and opposite charge will put it on the sphere. That will be the charge of the sphere. So sphere charge is +2. all right, which will help you in calculating the oxidation number of central metal atom. So tetraamine aqua bromido, Br is there, bromido. Remember I told bromide will become bromido, E will be replaced with O. So bromido, and after that, what is the name of metal? Cobalt. Cobalt, the Roman number we have to calculate. And what is the anion? This is nitrate. So we'll write nitrate. Okay. And you don't have to write the di-tri words for cation or anion. For cation anion, just the name is enough. You don't have to indicate how many of them are there. So di-tri, you don't have to use it for cation or anion. Keep that in mind. Now, how do we write the Roman? You have to find the x value here. So x will be, how do we calculate? So x minus 1 for bromine is equal to plus 2. So x will go, minus 1 will go on that side, so x will be plus 3. So it will be cobalt 3 nitrate. So this is the answer. All right, hope you are clear. Now we will discuss the third one. Now in third one, if you see, this is NO2. It is a special ligand, it's an ambidentate ligand. Which ligand? It is a ambidentate ligand. I think I have already told you for ambidentate ligands, there is a special rule. What rule says? Because it's NO2, its name is nitro. First of all, NO2 is nitro and ONO is called as nitrito. Okay, NO2 is nitro. So for nitro, the N is the donor center. When it's nitro, N is the donor center. When it's ONO, O is the donor center. So this N is basically the donor center for the central metal atom. So the additional rule for ambidentate ligands, it says that before writing the central metal atom name, you have to indicate the donor if it is the ambidentate. I will show you the name how. So first of all, see, this is nitro. This is the counter ion, so this is minus 1 into 2. So equal and opposite, the counter ion charge will be on plus 2, okay? On the sphere, equal and opposite will come plus 2 because this is an ion. Alright, now this is neutral 0. Nitro NO2 is basically minus 1. So what is the oxidation number of cobalt? What is the value of X? So X minus 1 is equal to plus 2. So X will be 3 plus 3. So we got it. Now how do we write the name? So please see here. So name will be amine will come first. So 5 is there. So pentamine, pentamine. Okay, pentamine. After that, and yeah, mainly students are confused when it's ending with penta is with A and amine starts with A. So do we write separate separate? Yes, you have to write separate separate. You can't write penta A and extend it with amine. You have to write two A separate separate. Penta A and amine A has to be separate. Okay. So pentamine, after that nitro, alphabetical order, pentamine, nitrito, then before writing the central metal atom name, I repeat, for whenever you have ambidentate ligands such as NO2, ONO, SCN or NCS. So before writing the central metal atom name, you always indicate the alphabet. Who is the donor center? So when it's nitro, N is the donor center. When it's ONO, who is the donor center? O. So before writing central metal atom name, you have to write N cobalt like this. Why are we writing this N? Because when it's an ambidentate ligand, you have to indicate the first alphabet. Who is the donor center? So nitrogen is the donor center in nitro NO2. So we will write N and then write the central metal atom name cobalt. Okay, that is the extended rule. After that, what we have to do? We have to indicate the oxidation number in Roman, that is 1, 2, 3. Enclose in the bracket, and finally you have to write the name of anion at the last. So that is nitrate. Done. So we will write the name nitrate. So I hope it's clear. Remember, this is the additional rule for ambidentate ligand that you have to indicate the first initial of the donor center before writing the central metal atom name. All right. Now we will go to the next part. We have some more questions to discuss. But before I do more questions, let me bring you back to the previous slide. So in the previous slide, if you see, that is what point has been explained here. Okay, that attachment in case of unidentate ligand, which is called as ambidentate ligand, the point of attachment in case of ambidextrous ligand with more than one coordinating atom is either indicated by different names like thiocyanato, isothiocyanato, or by placing the symbol, the donor atom attached. I think I have told you about this rule. You have to remember this. Placing the symbol of the donor, that is the first alphabet, okay, attached to the name of the ligand separated by hyphen. All right. So I'll give you one example here. So first of all, remember here, when it's SCN, it is thiocyanate. Okay, when it is NCS, when N is the donor center, then it is called as isothiocyanate. All right. So you can see in ammonium ion, this is ammonium ion. Its oxidation number is +1, and three of them is there. So minus +1 into 3. So total it is +3. So what will be the charge on the sphere? Equal and opposite. We will put 3 minus. All right. And then we know SCN is a negative ligand. Okay. Its oxidation number is -1. And now remember, because it's written as SCN, that means sulfur is the donor center. You can see sulfur is donating it to the chromium. So how do we write its name? So write the name of the cation first. So ammonium, number of ligand 6. So hexa, because sulfur is the donor center, so it's thiocyanate. Okay, when its nitrogen is NCS, then it's called isothiocyanate. Remember, nitrogen, whenever is the donor center, we use the word iso. All right, so it's isothiocyanate. Okay, for example, when CN is there, we call it as cyanate or cyano. But when it is NC, then nitrogen is the donor center, we call it as isocyanide. Okay, isocyanate. All right, or isocyano. Clear? So, so we were at hexathiocyanato. Now you have, because it's an ambidextrous ligand, you have to represent the donor center before writing the metal name. So sulfur is donating, so S. Then chromate, and we have already calculated the oxidation number C. If this is -3 and if it's -1 into 6, so how the calculation will be? X minus 1 into 6 is equal to -3. So x will be -3 plus 6. So x comes as +3. So we have got the oxidation number. So this is the answer. Now let's see one more example. So in this case also, if you see, there are two ammonium. So +1 into 2. So what will be the charge on this sphere? Equal and opposite. So it will be -2. All right. Understood? And remember, I missed to tell you one thing. I have told you that when it's an anionic complex, when the sphere has a negative charge, ending should be with ATE8. All right. Here also, if you see, there is a negative complex, so its ending will be with 8, ATE. You don't have to do that for positive and neutral complexes. Okay. So name of the cation first, so ammonium. 6 is there, so hexa, and because NCS, so it will be isothiocyanato. Because it's a negative ligand, so it's ending with the O. Then you can see nitrogen is the donor center to platinum. So in case of ambidextrous ligand, we use the donor center name. So first alphabet, that is N. Because it's a negative complex, so platinum will become platinate. And now let's calculate the oxidation number. So what is the oxidation number of platinum? So this will be X minus 6. It will be X minus 6 is equal to -2. So X will be -2 plus 6. So it comes as how much? It will be 4 plus 4. So in Roman we have written 4. I hope it's clear. Now let's do some more questions to have a better understanding. So finally, how do we name this ligand? Now you can see I've told you when it's NO2, it's nitro. When it's ONO, it is called nitrito. Alright, so how do we write its name? First of all, find the oxidation number of cobalt, X. Chlorine is a negative ligand, -1. Ethylene diamine is basically, or ethane 1, 2 diamine is a neutral ligand, so it's 0. This is -1. Whether it's NO2 or ONO, it has a -1 oxidation number, and you see there's a +1. So it's a cationic complex. So you don't have to write ATE8 in this case. So how do we write the name? So first of all, the rule says name the cation. There's no cation, and also there's no anion. So directly you start with the name of the ligand with number in alphabetical order. So this starts with C, this starts with E, this starts with N. So what comes first? A, B, C, D, N. So you will see C comes first. So we will write chloro or chlorido because it's a negative. So end with O. Chloride will become chlorido. After that you will have E. Okay. So it will be now, there is another rule. Remember, if you come across this ligand, which is En is called as ethane 1, comma 2 diamine. In this amine, you don't have a double M, okay, single M. Now, if you come across such ligand which already has a word di in its name, if you come across such ligands which already has a word di tritetra in its name, then to indicate when they are two, do not use di. For such ligands, we will use bis. Okay, for three, don't use the word tri for such ligand. We will use tris. Okay, and if you have four of them, then don't use word tetra. We will use the word tetrakis. Okay, tetrakis, bis, tris, tetrakis, pentakis, and so on. All right, and in case you don't write this kiss, don't write KISS or your ma'am or sir will get angry. Okay, he will angry. You don't want your teacher to get pissed off on you. So kiss mat likhna, don't use the word kiss, just write KIS. All right, now next. So remember, I'll highlight again what I said. Another rule for such ligands who contains the word bi, tri, tetra in its name, like En, ethylene diamine. Okay, for such ligand to indicate its number in the IUPAC rule, we will not use di, tri, tetra word. We will use bis, tris, tetrakis, and so on. Okay. So how do we write the name? So chlorido, C comes first. Then we will write bis because it's two of them. Bis ethane 1, comma 2 diamine, and you will see we will use the word nitro. All right, nitro. And finally, there is no cation, no anion. So we will write the name of the central metal atom, that is cobalt. But there is a mistake I did. What is the mistake I did? It's ONO, so it can't be nitro. Nitro is in NO2. ONO becomes nitrito. If you remember, nitrito, I know. Congratulations to people who got it, correct, that I am doing it wrong. And then you will write the word O, the donor center, which is in case of ambidended ligand. So nitrito, then you have to write N, sorry, not N, O is the donor center. So you'll write O and then cobalt. I hope it's clear, and write the oxidation number. So what is the oxidation number? We have got it here. You can see it's 0, -1, -1. So X minus 2 is equal to +1. So X will be +3. Clear? So cobalt 3, because there is no cation, no anion, so we'll simply write it as ion because there is a charge given. That's all. So this is the name. Chlorido bis ethane 1, comma 2 diamine. Nitrito because it's ONO. When it's NO2, it's nitro. O cobalt because ambidended ligand, so you have to represent the donor center, and O cobalt 3 ion. That's all. All right. Now finally, I am leaving up to you. This will be your homework. So do one thing. Solve this question, write the name and answer in the comment box below, and I will give you a reply. And if you want me to make such amazing videos, and you can just put your feedbacks on the comment. I'm definitely going to make it. And the Chakri Academy is with you in your preparation. So keep preparing and keep sharing the videos if you find it useful to your friends and anyone in need. I'll see you in the next video. Bye bye for now.